Okay, for this next section, we're now going to make sure we understand circles and arcs. Okay, circles and arcs. So I've highlighted and gave you some things to remember in regards to a circle. One, that's a central angle. Lowercase m means measure in degrees. We've got to make sure we can read that correctly. Central angle is when the vertex is at the center. Okay, so C is our center. So a central angle would be angle ACB would be an example of a central angle. And then the arc is what's in between that central angle, the curve, that's AB. And the measure of that arc is equal to the central angle. So if you look on here, we have 50 in the inside, so there's 50 on the outside, okay? And the major arc, if I was doing a major arc, that's an arc that's greater than 180, so you have 3 letters. And so down here, if you look, the major arc ADB, I should have did that in green. So that would be this piece, this curve here. And to get to that, I do 360 minus the 50, okay, because it has to be greater than 180, and then a full circle is 180. And then semicircle, in case, you can use that for problem solving, that's half a circle, which means it equals exactly 180. And remember that your radiuses are congruent, and sometimes they can make an isosceles triangle. So on our first section here, it says find the measure of from the circle below. So they want us to find the measure of arc QS. So here's Q to S, that piece right there. Now, in order to do that, I'm going to use some other facts that I know about a triangle. Well, I mean a triangle, a square. A circle. I'm sorry, it's been a long day, guys. All right, so if I look at RU, that's the diameter. And what a diameter does, it cuts a circle into 2 parts that are equal, which is 180. So I can use the fact that this whole side here would be 180 and over here would be 180. So I can add these up and then subtract it from 180. So I can add with basically the 47 and the 55 up, which would give me the 102. Sorry. And then take 180 and subtract from that. And that would give me my remaining piece, which is the 78. So that means this little piece here is 78, which means the arc would also be 78. Then I can also use vertical angles. 47 is vertical with the angle QPR. So this would also be 47. And now I can get to my blue arc. To get to the arc QS, I would take the 47 plus, sorry, it just paused on me, plus the 78 and get that arc. So hold on just a second. Okay, so I think it's working now. So we take that 47 and that 78. Let me extend, sorry about that. Let me extend this page up a little bit. Plus that 78, that would give me the arc QS. And so we should have 125 degrees. All right, so to get the remaining arc, which represents, and I'm going to highlight that one. Second question, arc Q, oh, RQT. So go in order, R to Q. Oh, let me do a different color. Apologize. Let's do this. Let's go blue. R to Q to T right there. All right, so to get to R, Q to T, remember I said diameter cuts the circle in half? So I have more than one diameter, guys. I have this diameter right here. QT, it's also a diameter. It's a cutie, perfect 180 degrees. So I can use that, this whole piece being 180, plus the other 47 to get to the major arc, RQT, which is 227 degrees. Okay? Now, remember I was talking about the radians, the radii are congruent. That helps you with 27. So I'm going to kind of talk about these a little bit more. I know I said we're going to do the left. I'm doing the left, you do the right. But I want you to be able to see this. Excuse me. So they want us to determine the measure of the arc. I know it kind of got cut off, but they want us to find the arc BC. Sorry. Arc BC here. If I know that the angle, was it the arc BC? No, it wasn't BC. It was, I have to check. I'm sorry. I think they want us to find the measure. Yeah, they want us to find the measure of angle BAO. So measure of angle BOC 54. This is a diameter. It makes a linear pair. So if I do 180 minus 54, I get central angle, the other central angle, which is 126. Excuse me. So then if I notice that O to A, that's a radii, O to B is also a radius, it's a radii together. That creates our isosceles triangle that we have here. So we know this vertex angle is 126. I'm talking about the triangle OAB. So the base angles are going to be congruent. So that means angle A and angle B are going to be congruent. So to get their measure angle, I can just say 180 minus the 126 and divide by 2. And that will give me each angle. So that means each angle is 27. And so if that is 27, and I think that's all they wanted on this problem. Let's just use that. So that's 27. All right, so on 28, using the same relationship, we're going to have to add some information here. Because now they want us to find the circumference. We know that the angle OBQ, this little piece here, is 30 degrees. PQ, this segment, this chord, excuse me, is 6 root 3. What is the circumference? Now, to get to the circumference, the formula is 2 pi r. So you need the radius. So we need this radius here, or this radius here, it doesn't matter, but we need to find the radius. In order to get to that radius, we're going to draw another radius that bisects this chord. Because there's a property that says whenever the radius or the diameter intersects a chord, it is a perpendicular bisector every time. So now I can make a special right triangle because I know the green was 6 root 2, the whole thing. So if this whole segment is 6 root 2, and that lets me know that each piece here is 3 root 2 because I just divided by 2. Okay, 3 root 2. And if I look, I have, and I'm going to trace it, bring it out so you can see it. So I have two right triangles in here. I'm going to bring them out to the side. We'll bring one of them out. This is 3 root 2. We have the 30 degrees here. So this represents the hypotenuse. This is the short leg. This is the long leg. And the long leg has the formula x root 2. Well, look at that. Well, guess what has to be our x? 3. Okay, it's in front of the radical 2. So that means our short leg is 3. And that means the hypotenuse, which is also the radius in the circle, is double that. The hypotenuse is always double the short leg. It's always 2x. So if I double that, that's 6. So that lets me know that the radius of the circle is 6. Okay? And so now that I have radius, I can figure out that circumference. Because our circumference is just 2 pi, 2 pi r. So 2 times pi times 6, which comes out to be just 12 pi. Because I think it says, leave in terms of pi. So sometimes you're going to have to use all of the stuff that we did prior to that to get to that answer. Because in that, we were able to see our long leg, see a short leg because of that 30. All right. So that talks about our circles and arcs and circumference. Just hit the fast forward button to get to our inscribed angles.